Hello friends, we are continuing with our next series of videos related to PID using machine learning. Now, today's topic is going to be on time series forecasting model. So, we are going to discuss multi-layer perceptrons today, MLP. So, as you can see on the screen, the time series forecasting is a technique for the prediction of events through a sequence of time. It predicts future events by analyzing the trends of the past on the assumption that the future trends will hold similar to historical trends. It's like you're forecasting the temperature of a day. You can see in the screen that suppose the temperature or any other parameters are changing with respect to fixed time, then it's called a sequential data and they are time stamped in the x-axis. So an MLP is a kind of artificial neural network. Now, an artificial neural network, as you know, is a computational model inspired by the biological neural networks present in the human brain. It consists of interconnected nodes called artificial neurons or perceptrons. Now, how MLP is different from normal ANN? So, MLP consists of fully connected neurons with a nonlinear kind of activation function organized in at least 3 layers. So at least 3 layer means 1 input layer, 1 hidden layer and 1 output layer. That is sufficient. Now we are using a simple MLP model that has a single hidden layer and an output layer which is used to make prediction in this particular case study or example. So while writing a Python program, you have to always define a model that will be a sequential model. The shape of the input is very important for defining a MLP model. The shape tells what the model expects as input from each sample. In our program, samples are the number of time steps. Choose a number of time steps. In our case, let's take n steps is equal to 3. This particular thing was earlier discussed in another video in the data pre-processing. Now, to make the concept of dimension more clearer, so let's think that dimension is equal to 1. That means dim is equal to 1. It implies that one array with n number of elements in it. For example, the continuous data which is flowing in from a temperature sensor, each represented like what, like 1, 2, 3 up to n. So that is with the dimension 1. And dimension 2 implies that m number of arrays with each array contains n number of elements in it. So you can say that it is m number of arrays with n number of elements. For example, if you write np.array, then 1, 2, dash dash up to n, then again one more array, then another set of samples. If you go on writing like this, then you can create arrays with 2 dimensions. For dimension is equal to 3 implies that the numpy array contains p number of arrays and each p contains m number of arrays in it. For example, if you look at the example below, you can see that the entire thing will have P is equal to 3. You can see that it's like 3 different frames, and each frame will have a 2-dimensional array. So it's like arrays being the frames being stacked. So this is P comma M comma N. That is how you can represent this. For example, let's take an example. You are having some numbers 1, 2, 3, 4, 3, 4, 5, 8, and so on and so on. So if you print it out, you can see how the array looks like. So now in this particular array, you can see that actually you have a group of 1, 2, 3, 4, 5, 6 such groups, and the array can be represented like this. So that means that this is an array of dimension 3, and shape of the array is represented as, it's like 2 frames, that is 2, and 3 by 4. Each inside is 3 by 4. 3 rows and 4 columns. So the input dimension for each sample is specified in the input dim argument on the first hidden layer. So this is how you write that: model.add dense layer, and this 100 comma activation is a ReLU function. Like you must have already studied, the activation functions could be ReLU or sigmoid. So in this case it's ReLU. So total number of neurons 100, and you have written the input dimension is equal to n steps. This way the model will consider each time step as a separate feature. So model is then fit using the Adam and optimized using the mean square error MSE for the loss function. You can simply write one single line which does that for the Adam optimizer and MSE loss function. Now the training starts. We consider epochs of 2000. Then model will be fit with minimum errors, and now we must reshape the single input sample to 2-dimensional. This is an important step for making the prediction. So for example, for x underscore input is, let's say, an array of 70, 80, 90, and you would like to predict the next number after 90. Then first thing what you do is x underscore input is equal to x underscore input dot reshape 1 comma n steps. This is what you do first. After the model is fit, we can use it to make a prediction, and at the end you will see the output after some time, but the complete program looks like this from beginning. Whatever we have defined, once more, is a sequential model, ReLU activation, number of neurons, then it's a optimizer Adam, and MSE is the loss function. Now you are reshaping the input sequence for prediction. The x input is 70, 80, 90. What will be the next value? That is what we want to predict. So first you do the x input reshaping 1 comma n steps, and y hat equal to model dot predict. That is what will give a predicted output. At the end it will print out like what you see on the screen. This is before reshaping 70, 80, 90. It looks like that, and this is symbol array. Now after reshaping, it becomes a matrix. Then the predicted output is 100, and it is very close to what we were expecting. So see you in the next videos. The series of videos will continue. Thank you.